Now, we are going to talk about hydrogen with a group of nonmetals, with a polyatomic. In that case, we actually have two rules on this. It depends on the ending. Does it end with ate, A-T-E, or ite, I-T-E? Let's see here. So here is our binary molecule, like carbon monoxide, CO2. Here's our binary acid, like hydrofluoric acid. And now we're going to split this into two. These are going to be our oxyacids, and they're called oxyacids because they have oxygen in them, a polyatomic with the hydrogen. So hydrogen plus our polyatomic, and if there's oxygen, we call it an oxyacid. Let's first start with 8. If a polyatomic ends with 8, I'll actually write that. Polyatomic ending in ATE. The contrast on this is a polyatomic ending in ITE. Ending in ITE. Okay, so if we have hydrogen plus this polyatomic, let's take H2SO4. All right, I see hydrogen and I see this polyatomic. What you have to do is look up the polyatomic. SO4 is called sulfate. Ooh, this is important. I see ATE. Here is your rule. You change the ending on the polyatomic to ic acid. So this is going to change to the ic acid and become sulfuric acid. Now this one's a little bit special. We add a syllable to it. If I just took sulfate, you would have sulfic acid. Sulfuric acid and phosphoric acid, chemists added another syllable to it. So a little bit special there. The big point though is that 8 changed to ic. Now I have a friend and mentor, another teacher, that told me a cute saying, and it so fits with Thanksgiving. I love Thanksgiving. I will eat and enjoy family, enjoy food, and I'll eat till I'm sick. And even when I'm completely stuffed, I'll take another piece of pumpkin pie. So from that, here's your saying. I ate too much, I got sick. So whenever you see 8, you think of this saying. I ate, underline that word, too much, I got sick. Underline the IC. So if anything ends with 8, you change the ending to ic acid. And notice something glaring. We didn't write the word hydro anywhere. Sulfuric acid. When you see the word acid, that tells you there's a hydrogen in it. Now let me show you how you get the H2SO4. Now this is not ionic by any means. These are covalent sharing electrons type of bonds, but we can use our ionic trick where you cross down charges. Not because that really happens, but just because it works. How's that? If I have sulfuric acid, first thing I do is write down hydrogen. I know that an acid has hydrogen in it. And then I look up, I see sulfuric, so I change that to 8, and I look up the polyatomic. What is sulfate? Sulfate is SO4 minus 2. Now if you take the charges, the 1 and the 2, that's where that 2 comes from, H2SO4. And again, is that true chemistry? No, but it works, that you'll be able to get the right chemical formula for that acid. Let's do another one with 8. So I have HNO3. HNO3. I see the hydrogen. Okay, this is going to be an acid. I look up NO3, and that is nitrate, ATE. Like, okay, change that 8 to ic acid. It now becomes nitric acid. Nitric acid. No hydro, no hydro. Okay, last one that you need to know. is if the ending is I-T-E, ite. So let's do, we're going to do HClO. HClO. This is kind of a funky name for a polyatomic. All right, I see my hydrogen, and then I see the polyatomic. So I look up the polyatomic, and this is hypochlorite, I-T-E. Let's underline that. Here is what you change that to. Anything that ends in ite with the hydrogen, the ending becomes OUS acid, us acid. Again, from my good friend, here's your saying. It takes two of us to fight. You can think about a sibling. Maybe you don't fight with your siblings. Takes two of us to fight. It reminds me of the Dr. Seuss book, play, we play all day, fight, we fight all night. Anyway, takes two of us to fight. Let's write that down. It takes two of us, so that's really your OUS right there, to fight. And that's your ITE. So change us, or excuse me, change ite to us. So if this is hypochlorite, we change the ending to hypochlorous. Hypochlorous acid. Wow, it sounds dangerous, doesn't it? Hypochlorous acid. Let's do another one. In fact, we're going to do one kind of similar to our nitrate. We're going to use nitrite. Let's do HNO2. I see the hydrogen, it's going to be an acid. So we focus on the polyatomic. I look it up, that is nitrite. Okay, great. I see the ITE and I think it takes two of us to fight. I change ITE to OUS acid. So instead of being nitrite, this is nitrous acid. Nitrous acid. Now there's a set of 4 that I want to give you because AP in particular loves these, and there's a good chance if you're in college, your professor loves these. And the reason why is they're tricky. They're tricky, and so students will get tripped up, and if they're going to make a mistake, this is where they'll make the mistake. Check out these 5 acids. HCl, HClO, HClO2, HClO3, HClO4. And AP expects you to know the difference between all those names, or a professor will have you name all 5 of those. So let's go through the rules. Okay, see hydrogen on all of them, they're all going to be acids. Ooh, check this one out. Binary acid, 1 hydrogen with 1 type of nonmetal. This is where I use hydro. So hydro, and then I take the chlorine, change the ending to ic acid. Hydrochloric acid. Hydrochloric acid. Now, the rest of these, I see hydrogen with a polyatomic. So I'm pulling out my polyatomic reference and I'm looking everything up. ClO, just what we had done, is hypochlorite. I see the IT at the end, so I know I change ite to us. Takes 2 of us to fight. Us and ite. So this is going to be chloris, OUS acid. Hypochlorous acid. Now I look up this one, and that is called chlorite. So I write down my chlor, and then I change the ite to us. So this is chlorous acid. Instead of chlorite, we change it to chlorous acid. Next, I look up ClO3. That's chlorate. Chlorate, A-T-E. Ooh, see the 8? I ate too much, I got sick. I change 8 to ic acid. Last one, I look up ClO4. This is called perchlorate. Perchlorate. I identify that ATE, I ate too much, I got sick. So we change that from ate to ic acid. It's perchloric acid. Now, a common question that students will ask me is, Mrs. Locke, do I need to change the hypo or the per? And the answer is no. The only thing you change is that ending. The ate to ic, the ite to us. Now, really naming overall, you guys, I'm so sorry, is a total mess. Of all of chemistry, I think it's the most disjunct. It's a lot of memorization. But there was an attempt, and I want to show you the attempt. The attempt at naming many, many years ago. The hypo means that there's one less oxygen than the chlorate. And when you see ite, that means that there's one less oxygen than the polyatomic, that's 8. And then the per tells you that there's one more oxygen than the 8. Let me give you an example with this. In fact, you've seen this a couple of times. Nitrate and nitrite. So this is your nitrate, that's your nitrite. Notice there's one less oxygen. But don't think, oh, 8 means 3 oxygens, ite means 2. It doesn't. It just means for these relatives, there's one less oxygen. Because look at this. I can have SO4 is sulfate, and then SO3, one less oxygen, is sulfite. That's your sulfite right there. So it just means one less oxygen. Doesn't necessarily mean 3 or 2 or 4 and 3. So if that helps at all, if not, you just take common polyatomics and you memorize those. Phew. There is naming covalent compounds.